I was at the store on the weekend. Now, some of you should know this about me, but some of you may not. I am crazy. I am cuckoo for coconuts. I love all things coconut. Except, ironically, M&Ms. Coconut M&Ms are no good. And M&Ms are one of my favorite candies. Coconut is my favorite flavor. And when I was in Vegas at the M&M store and I saw coconut M&Ms, I very nearly did a cartwheel. And then I got some, and they're disgusting.
That sounds disgusting.
And then I read the ingredients, and you know what the one thing that isn't in coconut M&Ms is? Coconut. None. Not even coconut oil. None. It is completely synthetic. And it was bad. But I am undaunted, and I continue to taste coconut things. So I was at the store, and I saw coconut Cheerios. And I was worried, Marcos. I was worried, but they were on sale, and I had a chance to win a Fitbit. So I bought coconut Cheerios. I tried them this morning. They were delicious. If you're in need of a new cereal, and I know you're probably not because kids don't seem to eat cereal anymore. But if you're in the market for a new cereal, I recommend coconut Cheerios.
What's your favorite coconut flavor?
Huh?
What's your favorite coconut flavor to eat?
Coconut flavor to eat? It would be coconut is my favorite coconut flavor to eat. I'm not so good on spicy coconut or, garam masala coconut. I like coconut flavored things.
No, not coconut.
Like, he's wondering your favorite coconut dish?
Coconut flavors. For what?
You can buy those ice creams that come in the fruit cup, like the actual fruit. I love those because it comes in a coconut shell. Anyways, they're delicious. Too expensive, but every so often they go on sale. Please make sure your work is correct. Which one? You can see how fast I'm going. Jeez. Thank you. Yes, it is 10. There's the first 10. Everybody should have been able to do those. There's no rule that says you have to do them in your head. Both of those would be acceptable for N. And that was all your work for the whole weekend. And, of course, preparing for your test, which may or may not happen tomorrow. Wait a minute, I said that wrong. Which may or may not happen tomorrow. You don't understand which one?
No, not the question, but I understand like why you can't tell us when the test is like.
Because I've been doing this for 20 years, Bea. And when I say the day of the test, I actually state it. There is always 10 to 15% of my class that isn't there. I have one student that I taught in grade 9, grade 10, and grade 11. There's an average of 8 unit tests per year. That is 24 unit tests that kid could have taken with me, right? That kid wrote 2 out of 24 on the day that they were supposed to happen. Amazingly, that kid always came down with something the day of the test. And that kid's mom or dad always said, oh no, that kid was sick. So now this is only your second test, so I'm being very lenient with it, right? Like, it may be or not be tomorrow, right? You know when your test is going to be. I'm not going to keep doing that because you should be ready for your test as soon as the unit is over, right? If you're going to be a kid that's going to skip tests, you might end up skipping a week before you get your test, which would not be very intelligent because I tire of it, because it really messes the class up, because I like to go over the test the next day while it's fresh in everyone's mind. But I cannot do that because I often have 5 or 6 kids that haven't written it because they think that I don't know how medicine works. Whoa. We all good? We can all multiply from grade 10, yes? All right. Now the next thing we are going to do is we're going to remind you about factoring. Some of you are very good at this. Some of you are kind of poopy at this. Factoring is the reverse of expansion. Here is what I mean. 4 times 3 equals 12. Those are factors. Anytime you break a number down, that's the wrong word. Anytime you break an expression down into parts, you are factoring. Now, we've already done this a lot. We did it with square root of 12, for example. We broke it down 2, 6, 2, 3. That's one kind of factoring. That's prime factoring. When we're factoring polynomials, we're often looking for pairs of factors, pairs of integer factors. So if we were factoring 12, we would want 1 and 12. 2 and 6, or 3 and 4. Everybody understand? This prime factoring, we do this for radicals. This is more what we're concerned about with polynomials. We're looking for pairs. Everybody good? You've done all 3 of these already in the 10th grade. You've done them to death. Some of you are very good at it, as I was saying. You can see them in your head. You don't even need to think about it. Some of you do need to think about it. There is no stigma associated with not being able to see these groups right away. All right? I tell a story often about a kid I taught about 10 years ago. What's 7 plus 2, kid? I don't know, Mr. Myers. What do you mean you don't know? I don't know. Can I use my calculator? That's how strong the kid was at math. We did factoring. He was in the 9th grade. Back then, factoring started in the 9th grade. I showed him how to do this once, and that kid, right away, I could write any trinomial. He'd be like, 3 and 4, 7 and negative 1, 8 and negative 7, right away. Every time. And then that unit ended, and we were back to, what's 7 plus 2, kid? I don't know. And all the other kids in the class were like, what the hell? And he was like, I don't know. I don't get it. I just see it right away. But you don't see 7 plus 2? No. It was the weirdest thing. So anyway, we will go on. Greatest common factor. This one is one you already know how to do, or that you do all the time automatically without thinking about it. Always do this whenever you can. So even if you know you're going to be doing one of the other kinds of factoring, but this is an option available to you, you should do it every time. Okay? And you already know how to do it. It's a 4-step process, 3-step process, actually. You already know what it is. 1, you get the GCF. 2, you divide by the GCF. 3, you write the answer as GCF quotient 1 plus quotient 2, and so on until you're done. You all can do this in your sleep. I don't need to review it heavily. Look at that. What's the common factor between 6 and 3? 3, right? So I've chosen my GCF. It's 3. I divide everything by 3, and I write the answer like this. GCF first, 3, and then I write each answer. 6x divided by 3 is 2x. 3 divided by 3 is 1. Easy. If there's variables, you have to account for the variables. So in this one, we only had 1x, so we cannot have a variable as part of the greatest common factor because this 3 has no x's, right? He's still single. These both have an x, at least one, yes? So you choose your GCF, which in this case is what number? 2. And what letter? How many x's? 1 only, because this guy only has 1 x to give. Then we write it out. 2x, GCF, and then all our answers. 4x squared divided by 2x is 2x. 6x divided by 2x is 3. Now, when you are factoring, you never, ever, 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 ever have to worry about whether or not you have done the question correctly, because you can always multiply it back at the end. 3 times 2 is 6x. 3 times 1 is 3. I did it right. 2x times 2x is 4x squared. 2x times 3 is 6x. I did it right. Everybody remembers how to do this, yes? Yes, yes? Okay, you're going to do this one by yourself. You're doing the one in red by yourself because everybody just said they knew what they were doing. Y cubed, x cubed on the last one. And yes, I changed the order on purpose. Ms. Doan, my favorite Doan.
Aww. Are you able to rep on Wednesday afternoon instead of Thursday? Chad Radins has a bunch of girls going to the Elite Sevens.
Does he now?
Yeah, that's what I said.
I am already reffing a game at Hanson on
Lovely.
Wednesday the 4th.
Thank you.
Wednesday the 4th is filling up. I got to ref a game. I got to go to your practice, and my son's got a meeting for his trip to Ireland. I don't think I can do all of them. I can't, because 2 of them are at the same time. And I know I'm awesome, but I'm not that awesome. I don't think I will, because my son is going to Ireland. Unless the school says we can't go because of coronavirus, which schools are just sometimes silly enough to do. Huh? Why? Because you're all sick? There's 3 million people in BC. There's 8 cases of coronavirus. 8. 3 million. Check your chances for getting it. Yeah, you can spread a cold too. All right, what is the GCF? This is tricky. Why are you saying -5? How can a negative number be the greatest common factor? because they all have a negative in them. It's a weird one, right? Sometimes we take out a negative, even though it's not the greatest common factor. And what letters? X squared and a single y, because he only has one to give. And then we write it out. Negative 5x squared y. And we get 5y squared plus 9 plus 13 xy squared. Now, this has a proper order it should be written in. I don't care. And nor will anyone else for a long time. Okay? Everybody good? All right. So all of you remember that. Easy peasy lemon squeezy. How many of you remember how to do these guys? Anybody? You remember? Because you're checking your multiplying page, right? You went a little bit ahead. Toby. They have to multiply to the other way around. Multiply to 7, add to negative 8. Okay? So, since I got to multiply to 7, I'm looking for pairs, yes? 7's an easy one. Why? So it's a prime number. It's only 1 and 7, yes? Does 1 and 7 make 8, negative 8 in any way? Yeah. How? Negative 1 and negative 7. Because negative 1 times negative 7 will give me positive 7, won't it? So my answer is x minus 1, x minus 7. Done diddly-un. Right? We all remember this, yes? Okay. Let's try another couple. I'm going to change the letter because nothing is more frustrating to math teachers than kids who say they can't do it when it's not an x. A squared minus, let's go with plus. Let's go with plus 12a minus 45. I need two numbers that will do what? Multiply to negative 45 and add to what? 12. Is it 1 and 45? No. Is it 3 and 15? Yes. How will 3 and 15 get me to 12? (15 minus 3), yes? So it is a minus 3 and a plus 15. Mr. Myers, did I do it right? I don't know, kid, did you? Is a times a squared? Is 15 a's minus 3 a's 12? Is 3 times 15 negative 45? Did you do it right, kid? Yes. Let's try another one. No, I don't want to use a. M squared minus 12, no, not 12. M squared minus 8m minus 20. And add to? Is it 1 and 20? No. Is it 2 and 10? Yes. How do 2 and 10 get me to negative 8? 2 minus 10, right? So m minus 10, m minus 2. Plus 2. Now, does this order matter? Could I do m plus 2, m minus 10? Yes. Could I do m plus 10, m minus 2? No. Everybody good? Okay, we're going to do one last one of these type, and then we're going to move on. Q squared plus 13QR minus 30R squared. Dun, dun, dun. Okay, multiply, add, negative 30, 13. What is it? I am sneaky. Is it 1 and 30? No. How many of you want to say 10 and 3 right away? Be honest, put your hand up. You all want to say 10 and 3. But it isn't 10 and 3, is it? Because it would have to be 10 plus 3, yes? And that would mean 10 times 3 positive, which would give me positive 30. So it's not 10 and 3. What is it? 15 and 2. 15 minus 2. But what else is there that's messing us up? Q plus 15 what? R times Q minus 2R. Right? Because that expression is a pirate. Pirates have trouble getting to movies. Kids are always rated R. Why do pirates never learn to read? No. Everybody says that one. That's why I tell the jokes in this order. Why do pirates never learn to read? No. No. They spend years at sea. No, the letter C. They spend years at sea. All right, what's wrong with the second one? Why don't we like it?
That was a good one. I have a new joke for you.
Oh, do you?
I'll tell you at the end. You can have it.
Okay. What's wrong with the second one? Got a 3 in the front. We don't like the 3 in the front. So, what do we do if possible? We GCF first. What's our GCF here? 3, because we want to get rid of that 3. Now, here's the mistake you're all going to make. You're going to forget to write the first 3. You're going to forget to write that 3. I'm telling you right now, when I mark your tests, I'm going to put a bunch of red circles in front of something and a question mark because you're going to forget to write that 3. Now, can we do that? Sure we can. What is it? I got to multiply to what? Other way around. Negative 8 and add to 6. What is it? You all want to say 2 and 4, yes? Does it work? No, why not? Because that's negative, right? So this would be done. It is just as important to know when you're done, right? Now, if I change that to plus, then this becomes super easy. Yes, what is it? X plus 4 and x plus 2. Everybody good? Okay, try this one. Let's go 4m squared plus 28mn plus 48n squared. What would you do with that?
We can just change the signs like that.
No, what I did there was originally in the original question, that was what we got, right? And we needed to be done because there were nothing that would work here. And then I said, what if I made it positive? Now it's a new question. And then we could actually do it. Okay?
Yeah, but we can change the.
No, Sophia. I'm trying to explain this to you. If I left it as negative 24, you would divide out the 3, right? Now, are there any numbers that multiply to negative 8 and add to 6? No. So this is done. Even though it looks like we could do more, it's done. A bunch of you will try to factor that. And I'm telling you, if you can't, you can't. Then I said, what if I changed it to this? Like, it's like a second question. Okay? And then, of course, then it would be x plus 4 and x plus 2. That's why I kept the colors. All right. What are you going to do with that blue one? What are you going to do with the blue one? You're going to take out the 4, yes? 4m squared plus 7mn plus 12n squared. What's that going to be? I got to multiply to 12 and add to 7. What is it? 3 and 4. M plus 3 what? What do I need to remember here? An n. M plus 4n. Good? Okay. Now, in the interest of laziness, I'm going to use a different color. And I'm going to make this cubed m, squared m, and a single m there. What would be the only change? Oh, I shouldn't have written it there. Sorry, everyone. That was dumb of me. Give me a sec. I'm going to make that m cubed there, m squared there, and put an m there. Then I'd put an m here, and what would go here? Another m, and then everything would be the same. Is everybody good with that kind of factoring? Right? You did it to death in the 10th grade, yes? All right. Turn the page over. Number 3. This is where it starts to get snaky. All right? And it's one of those things that a lot of teachers, they do the other two, and then they come to this one and they say, this one's an easy one. Kind of like when you were learning fractions and the teacher said, oh, we're at multiplying fractions. This one's the easy one. You just multiply straight across. Right? And you're like, oh yeah, okay, no problem. And then you realize that, wait a minute, it's actually a lot harder because then you got to simplify big numbers. Yes? This is the same thing. A lot of teachers get to different squares. They're like, this is the easy one. Chill out. And you're like, oh, I don't know. So, I'm going to write something down that you would never see written, but I'm doing it on purpose. X squared plus 0x minus 9. Would we ever write that trinomial? Why not? We would never write that 0, would we? But since I wrote it as a trinomial, let's pretend it's a trinomial. So this is just like what we just did, right? So I would need numbers that multiplied to negative 9 and added to 0. What are they? It's 3 and 3, right? 3 minus 3. So that's x plus 3, x minus 3. Now, this, of course, would not really be there, yes? That should really be x squared minus 9. And you should all already see and know the pattern from the 10th grade. X squared, square root, square root. 9, which is 3 squared, so it's a squared minus a squared, square root, square root. Right? All of you should see that pretty easily, yeah? So if I gave you this, y squared minus 25. What's the answer going to be? Plus 5, y minus 5. Ease, bees, lemon squeezy, yeah? 16y squared minus 25z squared. What's that one going to be? 4y, 5z, and 4y minus 5z. Can I forget all the other stuff I know in math? No, I cannot. So what if I gave you this? 3x cubed minus 75x. What are you going to do with that? It does feel like you can simplify it because you can. What would you do? You would divide by 3 what? 3x to get 3x, and then x squared minus 25. And then what would you do with that? X plus 5, x minus 5. Yeah? Okay, now remember, this is the easy one, right? This is the one that everyone's supposed to say, oh yeah, factoring makes sense to me now. But then, as always, teachers do things like this. X to the 8th minus 1. What's that? Use your prior knowledge. X squared became x and x. So what's x to the 8th going to be? X to the 4th plus, and then x to the 4th minus 1. Are you done? Why not? Because the 4 breaks down. X to the 4th plus 1. X what? Squared plus 1 and minus 1. Are you done? No, because squared breaks down. X to the 4th plus 1. X squared plus 1. X plus 1. X minus 1. Please notice it's the same thing. You're doing it over and over again, but it's not just square root, right? Everybody good? So what if I gave you $27 minus 48x squared? And then I rewarded myself with a sip of coffee for coming up with such a great question. Some of you would squeak like mice. You would simplify. What's the GCF? 3. So that would give me 3. 9 minus 16x squared. Now what? And? Yeah? Everyone's feeling good, yeah? Yeah? Okay, let us move on to the fourth kind, the kind that really everybody screws this up. Because I personally can think of 5 ways to do this kind of factoring. I know there's more. I can only think of 5. You have to decide on a way that works for you. Okay? So we're going to do, let me ask you this, and I know I won't get consensus. It's like asking what to get on a pizza. Is it better for you if I write one question here and do that one expression in all 5 ways I know? Or is it better to give you 5 different questions and do each one with a different method? Same expression, 5 different ways? Okay. All right, so the expression we'll go with is 3x squared. Let's go with no, can't do that. Let's go with 14. Plus 14x plus 16. Now, what bothers you there? The 3. So normally we like to divide it out, yes? Does 14 divide by 3? No. Does 16 divide by 3? No. So I've got to use one of the other methods. Method 1. This is the way I was taught when I was a kid. You take, I'm going to label these as A, B, and C. This first method is called decomposition. A lot of kids don't like it, but some kids are like, oh, that makes perfect sense. So I'm going to show it. If there is no number there, it's just a simple x, yes? But there is a 3 there, and that 3 means that no number there is 3 times bigger, yes? Everybody follows me? Normally we're used to having a 1 there, but it's 3 times bigger now, yeah? So normally with this, we would need numbers that multiply to 16 and add to 14, right? Right? Except we can't have that because this is 3 times bigger. So we have to do A times C to get 48. And then we follow the same rules. We need numbers that add to 14 and multiply to 48. Is it 1 and 48? 2 and 24? 3 and 16? 4 and 12? 6 and 8? Because we had, this is 3 times bigger. So we can't be using 16. We've got to use something that is 3 times bigger. 3 times 16 is 48. Everybody cool? So we know it's going to be 8 and 6, yes? And they're both positive, right? So what we do, it's called decomposition because we break this in half. 3x squared plus 6x plus 8x plus 16. Now notice 14, oh, that made the number disappear. 14 is still right there, yes? Now, I have that, and I have that. That, I can take out a 3x. That leaves me with x plus 2, right? I can divide out a 3x. This one, I can divide out an 8x, right? Or an 8, not 8x. Plus 8x plus 2. Now, what do you notice? There's a common factor, right? So the answer becomes 3x plus 8 and x plus 2. That's one method. That's what I was taught. Not a lot of people still use it. I stopped teaching it years ago. I would teach one of the other methods, and some kids would never, ever, ever, ever get it. And I'd say, okay, kid, I'm out of ideas. I'm going to show you the way I was taught in 1988. And I showed them this like, oh my God, I get it. So I brought it back. If you don't like it, don't use it, because you're going to see 4 other methods. Okay? That was method 1. This is method 2. And it is called, it has a name. I can't remember what it's called. It's got some dumb, like, slick sound. Oh, slide and divide, this is called. I don't like the name. It's lame. But this is another way that I learn, and this is the way that I show, that I showed any of you that were in my class last year. You start the same way, A times C. So in this case, it's 3 times 16, so it still is 48. So we still need to multiply to 48 and add to 14. So we already know that it's 8 and 6. And this is what we do here. We write x plus 8 and x plus 6. But the only reason we knew it was 8 and 6 was because we multiplied by 3, right? So we have to divide these by 3. Right? Because the only reason we know it's 8 and 6 is because we multiplied by 3. So we have to find out what it really is by dividing by 3. Would you ever leave that fraction? No. But it doesn't simplify, does it? It just becomes a mixed numeral, yes? So that's simplified. Everyone agrees? Would you ever leave that fraction? What is 6 divided by 3? 2. That's the divide part. Now we slide. Any denominators left, move to the front. 3x plus 8. No denominator left there, x plus 2. Everybody cool? Again, that's the way I showed. I know of a third way. I don't know what this way is called, but guess what? It starts the same way. We go with A times C, which equals 48, right? Everybody cool? And we know that it's going to be 8 and 6. Now in slide and divide, we started with x's. In this way, we keep the 3x plus 8 and 3x plus 6. And then we notice that there's a common factor here, right? So we divide that by 2, or by 3, because 3 is a common factor. X plus 2. And then we just kick it out of there. And notice we are getting the same number no matter what we do. Everybody cool? Then there's a fourth way. Orange. The fourth way I don't like doing because it's a guess. And here is what I mean. I know that this is going to break down into something plus or minus something and something else O plus or minus P, right? I know that's what it's going to break down into, yes? If it's going to factor. So I know that I need these two numbers to multiply together to make that, right? So I would say to myself, this is the fourth way, I need any two numbers that multiply, I need 2 factors of A and 2 factors of C. And then you just start guessing. 3 is easy because what are the only factors of 3? 1 and 3, right? So I know it's got to be 3 and 1 for the A's, right? What are my options for C? It can be 1 and 16, 2 and 8, or 4 and 4, right? So we got to guess. And this is why I don't like it. So guess. Choose one of those three.
4 and 4.
4 and 4. So 4 and 4. Now you go across. What's 3 times 4? And what's 1 times 4?
4.
Well, what's 12 and 4? That's 16. I needed 14, didn't I? So it can't be 4 and 4. So I try again. Give me another pair. 2 and 8. We know it's going to be 2 and 8, right? So let's watch. 3 times 8 is 16, yes? 2 times 1 is 2, yes? Can I make 14 there in some way? 16 minus 2, right? But that's no good because everything was positive here, right? Grr. So we keep going. And you keep guessing until you find the set that works for you. I don't like it because when this one's easy, 3 and 1, it had to be 3 and 1, right? But what if this one were 12 and this one were 18? Then I'd have 1 and 12, 2 and 6, 3 and 4. And my other pairs would be 1 and 18, 2 and 9, 3 and 6. Everybody understand? There's a lot of guesswork. When you learn one of these three, you always know the right answer right away, first try. Everybody understand? Now, a great many other countries teach this thing with the guesses and crossing and adding, and it's cool, I guess, but I don't want to guess if there's a way I can find it exactly. Do you understand what I'm saying? So you do what you see fit, whatever works for you, right? I just learned this Greenway recently in my quest to find better ways to teach factoring. This is something that I've seen showing up more and more lately. If you like it, use it. I kind of like it because it makes you do a GCF. But then I don't like it because in this case, we ended up throwing that GCF out, didn't we? And do we ever throw the GCF out any other time? No. So maybe you want to be careful with that one. Everybody cool? Want to try one? Okay, I'll write a new one. You choose one of the methods. Let's go with 7x squared. Let's go with So let me slide up a little so you can see all the three methods. This is not a bad one to try the guessing one on because 7 doesn't have a lot of factors and 6 doesn't have a lot of factors, right? So if you want to try the guessing one, this is not a bad one to try it on. Now let me ask you, should I do all 4 of the methods here with the screen off?
Yeah.
That would be good for you? Okay. Yo. Yes, of course they are.
Please excuse this interruption. Could the senior girls basketball team and their coaches please report to the rotunda? Only the senior girls basketball team and their coaches to the rotunda right now. Thank you.
Hey, man.
Did you get that link I sent you about that Goonies?
Yeah.
You might like that.
Uh-huh. When she gets back. All right, so everybody should have their answers in one of their three methods or four. I haven't done the guessy checky one yet. I'll just finish that off. One sec. All right. I'm sorry, Bea, I just had to shrink it down enough to get all three on the screen at once. So there's your answer. It's that. Now, if you actually watch the video, I do this where I got a wrong one. Okay? Let me show you what I mean when I do this wrong. So say I write 1 and 7 and 2 and 3, right? Because it was positive 7 and positive 6, yes? What's 1 times 3? 3. And what's 7 times 2? 14. 3 and 14 got me 17, so this works, right? Then there's group 1, x plus 2y, and there's group 2, 7x plus 3y. That one works. Order didn't matter. Everybody with me? Because if I put 7 and 1 and 2 and 3, it worked. Then I put the smaller one on top, and it still worked. Everybody cool? Now, what if I did this? 7 and 1, 2 and 3. What's 7 times 3? 21, right? What's 2 times 1? 2. Does that make my 17? No. So it couldn't have been 7 and 2 and 3 and 1. Everybody good? This way is really useful later on, right? The expressions are going to get very complicated, and being able to do this will help you later. But if your goal is to finish with math in pre-calc 11, like this is the end of your math journey to graduate and get out of here, then one of these 3 is better for you. Is everybody cool? I don't know what your math journey is going to be. You do. So you have to decide. All right? Everybody good? Okay. I got 10:42, which means you got 12 minutes. Practice, page 57 and 58. Whew, and 59. Barf. When do I expect page 59 done?
Tomorrow.
I expect it done tomorrow because you do not necessarily know if you have a test tomorrow. Okay? Radicals. No. This review. There was the test. Ooh, that was close. There it is again. This review, Jacqueline. Everything on page 51 to 53 remember we did all the test reminders? 51 to 53 is what your test is on tomorrow. What your test is on tomorrow. Yeah. Eventually, thank you, Toby, I needed that word. Eventually, you'll be writing a test on pages 51 to 53. And that eventuality may come to fruition tomorrow. Or it may not. Haley, I think they got back, did they not? Whoever was in the bathroom? Oh no, it was Ellie.
Yeah, I really need to review that, but I have my review for you. 51 to
That is something I need to do today.
I also
Yo.
well, Mr.
No.
Myers, I
Oh yeah, you can. One of each can be
I
out.
technically haven't left yet.
Yeah, I know, but
so
I'll
the
forget
next
if I don't do
10 minutes,
this.
If I don't leave, then I technically don't get a
Don't worry, I'll erase it.
Okay.
All right.
I have a good question for you.